Hello everyone, this is Mr. 13 Things coming at you in I think it's the fourth in the discussion of the unit circle working backwards. The working backwards really has to do with working backwards in time or forwards in time, going back to fourth grade and starting with the concept of an inscribed rectangle inside of a circle and then coming upon how we can go about really learning how to calculate or know the values, fundamental values on the unit circle all the way from 0 to 360 degrees, or 0 to 2 pi, or really 0 to 79 pi, if you would. The fact of how does one go about making the unit circle and trigonometric values be as almost as second nature as 2 plus 2 equals 4. And in many ways, geometry and the like is something we start doing earlier than kindergarten, if you would. Circles, triangles, etc. What I've done this time is I'm showing the whole a little bit more of the screen here so we can see what I've been doing over time. I'm using Smooth Draw 3.2.6 open source freeware, using Camtasia, though Cam Studio is in fact a very good freeware version for uploading videos and uploading them these to YouTube under Mr. 13 Things, also known as Silence Did Good, depending on which channel you go to. And what typically I've been doing is going through, and I'll go through here and show you the kinds of things you can do, change colors and the like, and brushes across the top here. So you might want to do that. That's kind of cool. Edit, undo, the kind of thing, Control Z. So pretty common functionality, but realizing that this program does not have two things, a circle drawer or a line drawer. That's very good. So what we're going to do right away is we're going to add a new layer. Makes it a little bit more complex, but a great thing to do. Add a new layer, and then right away we're going to import that layer image, which we've done over and over again, probably knowing where you keep stuff in a better organized way. It'd be great. And this time I'm going to move this over, if you would, and I'm dealing in the first quadrant, so I'm going to go here and I'm clicking up. You don't see me, I'm ending that there. I'm in layer 1. Now I'm in layer 2, which is as I draft, for instance, on layer 2 here, I can turn that on and off, and so that's a great value. However, on layer 1, once again, remember that we're dealing with the unit circle. The unit circle has a radius, so now I've got to make sure that you have things on, and that's where, in fact, it takes a little practice, but it is worth using layers when you're doing this stuff, and you'll see later why when it comes to making quizzes and the like. This is a pretty important skill to kind of learn to use a number of layers. It goes into CAD, goes into Photoshop, the GIMP, so learning to use layers and practicing a little bit, but you're not, completely screwed up if you don't use layers. So what I'm going to do here is remember that we have, looking at the unit circle, the unit circle has a radius equal to 1 and a diameter equal to 2, and the area equals pi r squared, but an area equal to pi, and then the angle, so I'll say the angle is 2 pi. Students seeing these over and over and over again, writing all of these things is a good habit to develop, so later on over time they don't get messed up with when we start using area values versus radius versus angle values for all kinds of different definitions. Once again, I want to go back to layer 1 now and get my eraser tool, and we're going to be looking again finally at this video, make the eraser bigger. We're going to be looking at the values basically at 15 degrees, or pi over 12. Remembering that looking up into the sky at night, the sky is turning, actually it's the Earth turning, 15 degrees about, very close to that, or pi over 12, 24 hours in a day, 2 pi radians, so pi over 12. So this most logical definition that you don't see most anywhere, one of the most logical definitions over time, is this angle value here, which is this 15 degrees, and I'm going to go ahead and show it now. That is 15 degrees, or essentially a 24th of 2 pi, or pi over 12. So knowing the value here fills in basically the circle. it avoids having all these holes that you don't really own, if you would. So let's go back to what we know. When we start this, we know 1 and 0, and we know 0 and 1, right? 1 and 0, 0 and 1. And right now we're not going to talk about sines and cosines so much as values. And if you remember going through it, 1, 2, 3, 1, 2, 3, square roots, the value here was the square root of 2 over 2 and the square root of 2 over 2. This one had more x than y, and so it's the square root of 3 over 2 and then 1/2, with the square root of 1 being 1. So we have the values here, but what about the values here? The one that are left off, if you do a Google search on images or look in textbooks or whatever you're going to do, you will find they almost never teach this one. And remembering that if we know this one, we know that this is going to be the values flipped, just like these are flipped values, if you would, because there is a line of symmetry. I should learn that symbol. Line of symmetry right there at 45 degrees. So how do we go about getting these values? Later on, you're going to see there's some really good approximations for small angles, but we're going to go ahead and open up the parentheses, and we're going to put a comma here, and we're just going to do this. We'll do the first one, and then we'll do the second one. And the pattern is not 1, 2, 3, but 2, 4, 6 with a plus. And what you're going to see is it's going backwards. And you're going to see later why that's the only logical way for that to go. 2, 4, 6. And then you can also introduce the same pattern, 2, 4, 6, with the square roots here with a negative. And what you see here is this is kind of, if you would, kind of looks like the conjugate. I don't know that it is the conjugate. It's the conjugate of, it actually is the conjugate of this here. So you now have the values for 0, pi over 12, pi over 6, and pi over 4. And in that, when you go through the process that I'll review here of being able to find any point on the circle, drawing the inscribed box, right, if you would, back over to here, because that was 2 over, so that kind of goes across to, this one should be somewhere in there, it goes across to there, and then this being the reverse of this, right? So you reverse, right? That gets you the values of the magnitudes of the x and the y. So in this case, this is going to be, you're going up to there, you're going to reverse the values. So the values here are 1/2 and the square root of 3 over 2. And then you just have to figure out that this is a negative x and a positive y, and you have the values for that point on the circle. The key thing I want to show here is by leaving out the definition of pi over 12 to students, because it doesn't fit into a convenient pattern, you keep them from finding or finding sub-patterns inside of work or inside of numbers. So whereas this 1, 2, 3 pattern is clearly taught in many places, you don't see the 2, 4, 6 pattern except if you get lucky on Wikipedia. And so in the end, students can not quickly, but develop that concept of 4 points on a circle. How hard can it be? And I will write them. So we're going to go with the angle in degrees. So the angle in degrees. And angle, well, I'm going to go ahead and let's try the whole erase here. Try to erase this out here. Edit. Cut. Right, or I could go to a new layer, but I'm going to go ahead and when you go back and forth, you have to go back and forth on these tools sometimes to clear the pen. A little bit obnoxious, but it is open source. We can go with the angle, okay, angle in degrees, and the angle in radians, and then in fact the x value and the y value. And if you start with 0, remembering the Earth turns in an hour, pi over 12, and the next hour it's then twice that, pi over 6, and the next hour it's another pi over 12, which gets you pi over 4. Did that wrong. I'm going to go ahead and erase. See if I can do that. Make a new one. I can do edit cut and then edit paste. I can move that over here, right? So now you made that nice little mistake. Your kids, your students will be much better at this than you are. I was in a technical college classroom for 10 years. They weren't necessarily better than me at doing this. So 0 degrees, 15 degrees. You can probably write 15 better than that. 30 degrees, and then 45 degrees. And if you know these 4 points, you pretty much can deduce the rest of the unit circle. Remember, the x is 1, the y is 0. In this case, the x is more than the y, so it's the square root of 6 plus the square root of 2 all over 4. And this is the square root of 6 minus the square root of 2 all over 4. This one, the x is more than the y. It's the square root of 3 over 2, square root of 3 over 2, and this is 1/2. And these, the tangent of 45 is 1, or these are the same, the square root of 2 over 2, the square root of 2 over 2. So, working backwards, you can use this pattern, right? The two patterns of 1, 2, 3, 2, 4, 6, the pattern of reversing about the 45-degree line, and the pattern of drawing an inscribed rectangle to get to basically any cosine and sine, and then effectively tangent of any point on the unit circle. You know, I'm going to say any point, I'm going to put an asterisk here, any point at 15-degree increments. And that gets you awfully close for government work. So let me go through. In the last video, which is the summary of for the last quiz, it's then how do you go about and catch any point. So pick a point on the circle, give me the value, and then do it quicker and quicker and quicker until you own it, like 2 + 2 = 4. Thanks for listening.